Welcome to qnawire.
Okay, we've got to identify the labeled stereocenters. This molecule, I'll label them in green. 1, 2, and 3. That's RS. Okay, well, let's start with the first one. The most important thing we can do is label the priority of the substituents that the carbon is attached to. The highest priority I can see is this nitrogen, because nitrogen is a higher priority than carbon, and the other bonds are all to either carbon or hydrogen. And likewise, the lowest priority is in the back with this hydrogen, right? So that leaves these two carbons, the one with the double bond to the oxygen and the one with the single bond to sulfur, for us to determine which is higher priority. So we can say there's carbon bound to, in order of highest to lowest priority, sulfur, nitrogen, and hydrogen. And the other carbon is bound to oxygen, and nitrogen, right? And to determine which of these is higher priority, we need only look at the highest priority substituent each is attached to. And then if those are the same, we'll continue on down the list. But if they're different, then we can stop and assign the carbon that's attached to the higher priority substituent a higher priority. So sulfur versus oxygen, sulfur wins, therefore this carbon wins, therefore this carbon has a higher priority than the other. So we'll call this priority 2 and this one 3. And now we just need to determine if connecting the highest 3 priority substituents would give us a counterclockwise or clockwise rotation. This looks clockwise to me. And then since our lowest priority substituent is in the back, clockwise corresponds to R. Great. Let's continue. Let's continue with the stereocenter I've marked in blue. Why not? Okay. Once again, the lowest priority is this hydrogen in the back. In this case, we've got the difference, or 3 different substituents are sulfur, nitrogen, and carbon. So that's pretty simple. Sulfur is the highest, nitrogen is the second highest, and this carbon is number 3. Once again, this appears to be clockwise in order, which suggests that this stereocenter is R. Okay, last one, I will color in red. Now we no longer have the hydrogen in the back, so that's going to matter in a bit, but let's, in the meantime, start numbering our priorities of our substituents. As we know, hydrogen is the lowest, we'll call that 4. This nitrogen off to the side is going to be higher than either of the 2 carbons we're also attached to, so let's call this 1. And now we've got to compare these 2 carbons, which I'll color green. Right, we've got a carbon that's attached to a carbon, a sulfur, a carbon, and a carbon. That's the upper one, sulfur, carbon, carbon. And the lower one is attached to an oxygen, an oxygen, and an oxygen. If you're not sure how that works, it's because that's the functional group, so it's connected to that oxygen twice. Okay, given that, we need only look at the first substituent, which will be different between the two, which is sulfur versus oxygen. Sulfur has a higher priority, so therefore carbon, this carbon in green, this upper carbon in green has a higher priority. So we will label this 2 and this one 3. And then here's the tricky part. Okay, this definitely looks clockwise, right? But it doesn't correspond to R. It's not R. And that is because our highest priority substituent is not in the back. If our highest priority substituent is not in the back, clockwise will correspond to S. So whenever you have your highest priority substituent in the front or to the side, anywhere but the back, clockwise corresponds to S and counterclockwise corresponds to R. And there we go.